Bismillahirrahmanirrahim. Assalamu alaikum dear students. Welcome back in lecture 02 part 10. Student, make correction for the previous lecture, that was the derivation of the effective depth equation, which is D minimum is mu divided by 0.205 fc prime into b under root. So this is lecture 02 part 09. I have recorded as lecture 02 part 8, but this is that lecture is actually 09 part 09, right? So make correction for this. This is lecture 02 part 10, right? Now in this lecture we will calculate the wall loading and the loading of lintel in case of masonry work. Now we all know that how to calculate a wall load. If let's say we have a beam, and it supports a wall, so how to calculate that wall loading per running feet or meter? So let's say that if we have a wall right here and it is supported by this beam, right? So the calculation is quite simple. We just need a UDL, because the wall loading acting like a UDL, right? So that why if it is acting like a UDL, so we can designate this as like in this shape. So we need the height of the wall, that is denoted by H. We need the thickness of the wall, that is denoted by TW, right? And we need the length of the wall, that is denoted by L. But most of the time we take the length equal to 1 unit or 1 feet or 1 meter. So we calculate the loading per running feet or running meter, and that is designated as W pound per running feet or kilonewton per running meter. So this is a kind of designation of wall loading. So how to calculate it? We can easily calculate it by we can write down the equation, right? UDL on the beam will be equals to the density of the masonry wall. So masonry wall density, now the density of the masonry wall is taken as 1930 kg per cubic meter times, because this is the density of the masonry wall times the thickness of the wall, that is TW, and this thickness is almost in centimeter or in millimeter, so it divided it by 1000 to convert it into meters. If the thickness is in millimeter, then divided by 1000. If it is in centimeter, then divided by 100 times the height of the wall, right? If the height of the wall in meters, so it's okay. If it is in millimeter, divided by 1000, multiply by the 9.81 divided by 1000 to convert it into kilonewton per meter, right? So that's why it is multiplied by 9.81, because we have kgs right here. So kgs, if you want to convert kgs, because we know kgs equals to 9.81 kilonewton, divide by 1000, because 1 kg is equal to 9.81 newton. If we divide it by 1000, so this comes out, the answer will be comes out in kilo, right? So that by dividing it by 1000. So to take the value in kilonewton. Now if we multiply these values, what we got from this 0.019 TWh, this one will be in kilonewton per meter. This equation will be used in SI units. If we convert this factor to US customary units, this kilonewton will be converted to kip per feet. So the value will be 0.12 TW into H. The conversion is simple. We have just convert this kilonewton to kip and this meter, because we know that 1 kg equals to 2.204 pound, right? And 2.204 pound or 1 kg is also equals to 9.81 Newton. So what should be the value of pound in newtons? So pound 9.81 divided by 2.204. Alright, so from this we can got that 1 pound will be, I think so it is 4.4 something, right? Let me do the 9.81 divided by 2.204, 4.45. So it is 4.45 Newton. So 1 pound equals to, we know that 1000 pound equals to how much kilonewton? So divided by 1000, we got the value in kilonewton. So this is the conversion, right? This is the way that how you can convert this into the US customary units, right? So this is the way I have just give you the idea that how you can convert a Newton to pound, right? And we know that 1000 pound equals to 1 kg, right? And thus using this conversion you can do this calculation. This is simple. Now we need to find out the unit weight of per running feet of the lintel. This is important question, right? This one is important. So let's see how to do this calculation. Remember that this is my lintel and this is the clear span of my lintel. So here we can see the lintel beam, right? This is lintel beam, and here you can see this is my effective span, right? This is my effective span, which is someone inside the wall. And remember, the weight of the masonry structure over the lintel beam, it is considered as an equilateral triangle, right? This angle is 60 degree, this angle is 60 degree. This is an equilateral triangle, right? This is an equilateral triangle. Equilateral triangle, because this angle will also be equals to 60 degrees. So all angles are same, therefore this side will also be same, and the length of this triangle is equals to the effective length, that is L. Now the height of this triangle, which is from the center of this side to the top, it is determined for an equilateral triangle is 3 divided by 2 into L. You can derive this by just consider a right angle triangle like in this shape. This angle is 60 degree, right? This side is L02. We need this H. This side will be 30 degree, right? So that way if we use the tangent relationship, tangent 60 equals to H divided by L divided by 2 under root, and from this we can find out the value of H, which is L by 2 into tangent 60. And if you find out the angle tangent 60, please check it, but it will be equals to 300 root, so that why it is equal to 300 root divided by 2 into L. This is the way that how we can prove how this height equals to 300 root divided by 2 into L. Now we need the area of this triangle multiplied with the thickness of this triangle, that is TW, and we got the weight of that triangle. So let's do the calculation. The calculation is simple, right? So how to do this calculation? Weight of the triangular wall portion, right? Weight of the triangular wall. Now this triangular wall, right? So it will be equals to, remember the density of the masonry wall in kilonewton per cubic meter is 18.9. So density times the area of this triangle. The area of this triangle will be 1/2 times the height of the triangle, that is 300 root divided by 2 into L into base, right, and into the thickness of the wall, right, and divided by 1000 FTW in millimeter. So by just using your calculator you can find out the 8.18 L square TW divided by 1000. Now this is the triangular loading, right? This is a triangular loading. Remember, we have beam and we have load like in this shape. This is triangular loading. That load is 8.18 L square TW divided by 1000. Now we need to convert this to an equivalent UDL. So the equivalent UDL for bending moment, equivalent UDL for the bending moment, it will be, as we already recorded in lecture 008, that a triangular load will be converted into equivalent triangular load by just multiplying that load with a factor, right? F times the load, that is 8.18 T L square TW divided by 1000. Now that factored is for, that is 4/3. That factor is 4/3. Please watch that lecture, that is lecture 02 part 8. I have derived this, and this is 8.18 L square TW divided by 1000. Divided it by the length of the beam, that is L, right, to convert this into kilonewton per running meter. So L cancel with this L. So finally what we got here, 0.011 L into TW in kilonewton per meter. This equation will be used in SI units, and if you convert this into US customary units, what we got here, 0.0058 LTW kip per running feet. This will be used in US customary units. So these two equations will be used for determining the load of the lintel per running meter per running feet for a masonry lintel, while this two equation will be used for the wall loading. Thank you for watching. See you in next lecture.